Welcome to 24 Hours of Past Summit Preview 2015. We're excited you could join us today for Bertrand's session, 50 Things All SQL Server Developers Need to Know. This 24 Hours of Past event consists of 24 consecutive live webcasts delivered by expert speakers from the Past community. This session is a preview of one of the many technical sessions that will be presented at Past Summit in October this year. Recordings will be available in 1 week at www.24hoursofpast.com. My name is Andrea Allred, and I blog at royalsql.com. Catch me at SQL events dressed as a princess. I have a few quick introduction slides before I hand the reins over to Aaron. He will speak for 40 to 45 minutes, and then we'll move on to the Q&A, where you can ask any questions you may have. If you have any questions, or if you're experiencing any issues, just type your question into the questions pane on the GoToWebinar control panel, and someone will assist you. Feel free to enter your questions in the Q&A field at any time. Once we get to the Q&A portion of the session, I'll read off your questions to Aaron. Since all attendees are muted, you will need to submit your question by typing in the Q&A field. Also, there will be a short evaluation at the end of the session. Your feedback is important, please, to us, so please take a moment to complete it. It will appear in your web browser. The staging of 24 Hours of Past would not be possible without the support and dedication of our sponsors. They are the reason this event is available to you free of charge. I'd like to take a moment to thank our presenting sponsors, Microsoft, Dell Software, and Idera. In addition, I'd also like to thank the supporting sponsors for this event, HP, SQL Sentry, and Pyramid Analytics. Next, I'd like to bring your attention to the upcoming Past Summit, taking place in Seattle, Washington from October 27th to the 30th. Past Summit 2015 will feature over 200 sessions with world-class SQL Server experts. Planned and presented by the SQL Server community for the SQL Server community, Past Summit is single-handedly the largest gathering of SQL Server and BI professionals in the world. With over 5,000 registrants from all over the world, Past Summit is also a great place to network and meet face-to-face with experts, peers, and MVPs. More importantly, the Past Summit delivers on providing you with the answers to your SQL Server issues, along with knowledge, strategies, and skills that you need to stay ahead of the curve. Save $200 right now by using the discount code 24HOP15 when you register. Optimize your savings by registering before the end of Sunday, September 20th. To find out more, go to about Past Summit, visit www.pastsummit.com. Make sure you explore everything Past has to offer for the data professionals. You can join local user groups around the world, virtual chapters, find free online resources through our Learning Center, and read up on the latest community news in the Connector newsletter. For those interested in business analytics, check out the Past Business Analytics Conference happening in May next year. Visit www.pastbaconference.com for more information or to subscribe to our bi-weekly BA Insights newsletter. And now, please allow me to present the speaker of the hour, Bertrand. Aaron is a senior consultant for SQL Sentry, makers of performance monitoring and event management software for SQL Server, analysis services, and Windows. He blogs at SQLperformance.com, has been a Microsoft MVP since 1997, is the 4-time SQL Cruiser, and speaks frequently at various community events. Aaron, take it away.
Thanks, Andrea. So today I wanted to talk about a little subset of what my pre-con at PAST will be, and at PAST Summit. And this will be 50 things all SQL Server developers need to know. I'm going to show a small subset from these areas: development environment configuration, database design, Transact SQL, and query tuning. So for the dev environment configuration, one of the things that I've come across quite often in my career is it worked on my machine, and it makes it very hard to troubleshoot issues when people have a development environment that's configured in a way that doesn't quite match what production is. So it's really hard to troubleshoot things that way. So what I recommend to people typically is to develop on standard edition when possible. This is important if your production environment is not all enterprise edition, which is probably quite a few of us. What ends up happening when you have production or enterprise edition on your workstation or developer edition is you end up using features that can't work in production. So you partition a table, or you're relying on being able to use online indexing or things like that, and you never test the scenarios where those things can't actually work in standard. Another one is when you end up deploying to a case-sensitive collation. You kind of want to code for the principle of least surprise here. You don't want to develop in a case-insensitive database where you have all these things where you have parameters with different case and strings that are supposed to match with different case, and then you deploy to production where you have this case-sensitive environment, or someone applies a case-sensitive collation, or it gets moved to a case-sensitive server, and then all of your things break. So those are two things that you can do in your development environment to make sure that you don't have any surprises in production. A few more, you want to simulate production as best as you can. So you want to match the hardware and match the data. If you have room to store a dev copy of the entire database, you should do that. What I find a lot of people do is they fill up a table with 10 rows, and they have an orders table with 10 rows and 5 customers, and they run all these queries, and hey, everything worked great on my machine because it's fast and there's not a lot of data there. Well, when your database gets to 1 million rows, you want to be able to simulate that as well. You can also use stats-only databases. So I find that a lot of times people will get different plans in their development environment than their production environment, essentially because they have very different data. So a stats-only database, sometimes called a clone database, this is a way to tell your development environment, even in the case where you can't store the entire database, this tells your environment that there are this many rows in the table when there aren't really. So you can script out an empty database that takes no space on your disk at all, but SQL Server can think there are 8 trillion rows in that table based on the stats. So that's one thing that I'll be talking about in the pre-con, how to do that. There are also undocumented update stats commands where you can tell SQL Server directly, hey, this table has 500 rows, but I want you to pretend it has 5 million. You can also do things like simulating slow storage. So a lot of us have laptops and development environments now that have SSDs, and it's really hard to get a picture of what your I/O constraints will be like in production when you're developing on a machine with a very fast disk. So you can simulate slow storage by using thumb drives or external 54K or 7200K hard drives. So you can put your data files, your log files, and your tempdb on drives like that and really simulate slow disk. You can also simulate slow network by making sure that this doesn't really simulate slow network, but it simulates slow activity due to logging. So you can set up aggressive log shipping on your local environment, even if you don't have a domain and you can't set up AGs or something to simulate what's really going on in production. You can also trick the optimizer with a couple of statements like dbcc set weights and dbcc optimizer what if, and I'm going to show a quick demo on that. Now I can't switch to, there we go. All right, so I'm going to use AdventureWorks, and I'm going to clear the procedure cache and the buffers to make sure, make sure you don't think I'm fooling around with you. So we have a store procedure here that just does a select of 6,000 rows from sales order header and sales order detail. So I'm going to create that store procedure. Now I'm going to turn on trace flag 3604. This allows me to put dbcc output to the results pane. Then I'm going to take a look at dbcc optimizer what if and see what the status is. And so we've got a bunch of things here, a bunch of things you can change. Basically what optimizer what if does is it tells the optimizer, or it asks the optimizer, what would you do, how would you generate this plan if I had this many CPUs? So you might have a workstation that has 4 CPUs, but your production machine has 64. Well, you might want a better idea of what kind of plans you would get if your local machine also had 64 CPUs or a terabyte of RAM. things that you can't do by just throwing hardware at a laptop. Right, so there are a bunch of things here. A lot of these things you'd have to ask Paul White what they do. I have no idea, but there are a couple of very simple hardware ones that we can play with here. There are also weights that you can apply. So you can tell, by default, SQL Server considers CPU and I/O to be of equal weight, meaning that it will optimize for one or the other, but it treats them the same. And now you can use DBCC set weights to, or DBCC set I/O weight and set CPU weight to make the optimizer favor I/O much greater than CPU, or vice versa. So if we take a look at test settings, the store procedure that I just created by default, and we take a look at the plan, we've got a little bit of parallelism here. And then if I say, what if I had 64 CPUs, and what if I had a terabyte of RAM? And we run that. And then we run the procedure again. You won't see much different in the visual plan, but if you go into the details and dig into this, you'll see that there are different costs associated, and there are a different number of threads that actually ran. You can also simulate max.1 by setting optimizer what if to say you have one CPU. So this will allow you to do this in your session without changing the statement, because you might not want to mess with the actual query text. And it also prevents you from having to use things like resource governor or using SP configure to change the server-wide setting. So you can say DBCC optimizer what if CPUs 1, and then run your store procedure, and you'll see that the parallelism went away. So now we have nested loop joins, and there's no more parallelism. And to put things back to normal, we just say reset all. DBCC optimizer what if reset all. Now we can also take a look at what this does to the plan if we change the CPU weight. So I want to favor CPU 1,000 times more than I/O, which isn't very common. Usually people will end up doing the other way around. And we look at the plan, and you'll see we get the parallelism back, and we have nested loop joins. So you can really change the way that that the plans come out. Now, if we change it so that I/O is favored much higher than CPU, and then we test again, you'll see we have a slightly different plan. So now we have a hash match, and we have repartitioning, and we've got a bunch of different things. The point isn't the details of what these changes did to this query. It's more the concept that you can make the optimizer consider your hardware differently than it actually is. And we put everything back to normal by setting the weights back to 1. And then this is for me, that's my little cleanup. And then we switch back to the deck. All right, so some items for database design. One of the things that I see a lot on Stack Overflow and DBA.Stack Exchange and MS SQL tips are people using the wrong data types to store their data, or to use, or variables or parameters. So I see things all the time, like people storing date or time data as strings because they want a specific format. And I have to remind people all the time that the format that the data is stored in has nothing to do with the presentation tier. So you want the data to be right. In this specific case, when you use a string to store a date, you lose all kinds of things like validation. You get built-in validation with a proper date time type, which you don't get with a string. And you have all kinds of operations. All of the date functions do not work against the string unless you happen to use a format that is consistently interpreted as the correct type. Another thing I see a lot is people use date time across their entire schema, even in cases where they never have time, so a date would do, or when they don't care about granularity less than a minute, so small date time would do. the big thing here is that people always say, well, I'll just use this because it's 8 bytes and who cares, disk space is cheap, even though date could be 3 bytes and small date time would be 4. Well, disk space is cheap and it's getting cheaper and it's getting faster, but that's not all of the picture. You also have to think about the size of your tables and your indexes when you bring them into memory. Memory is not cheap. Memory is not getting faster. So the more pages you have, or the wider your columns are, the more pages you're going to have for the same amount of data, and that ends up costing you a lot in the long run. I see people storing duration in a time data type. So this is bad for a couple of things. One is you can't use addition or subtraction against that duration. Another is that you have to add an extra column if you have a duration that's longer than 24 hours, because time only stores up to 23, 59, whatever. I see people using max types for data with known bounds. So an email. You don't need to use varchar max for an email. The longest email, and I would smack someone if they had this, is 320 characters by the standards. The longest URL, depending on the browser you're using, is 1,024 characters or 2,048 characters or something. There's no reason to use a max type which comes with a bunch of other limitations for something can't be longer than a certain length. But I think people are just, lazy isn't the right word, but they're not bothering to research, well, what do I really need to constrain this to? They'd rather just leave it open so people can type in whatever they want. Another one is using Unicode for things that could never possibly contain Unicode characters, postal codes and phone numbers. These are never going to contain a umlaut or some Chinese character. It's just not in those standards. And on the flip side, don't use varchar for proper names. So names of companies, names of people. You are eventually, your test data probably doesn't have it, but you're eventually going to come across people with names that have characters that aren't covered in the Latin character set. And so you need to use Unicode for those things just to be prepared. It's much harder to change varchar to nvarchar later than to just start with nvarchar from the start. Another thing I see quite often is people storing redundant data in the tables. So they'll have aggregations or calculations, date parts, concatenations, basically anything that can be calculated from the data, and they'll add a column because they think it's more efficient to have a column that already has that pre-computed than it is to generate those calculations or date or concatenations at query time. This is usually premature optimization. There are probably many cases that I could show you where it actually makes sense to pay the cost of computation at write time instead of read time, but don't do that by default. You're just making your databases, your tables bigger, your indexes bigger, and this goes back to what that costs you, not in terms of disk space, but in terms of I/O and memory. Another one is column stuffing. So people will store arrays or CSVs in a column, so they'll have a list of pet names. And now it's very convenient because up front they got to create this simple table, and then they have 18 questions on Stack Overflow about how to find all of the people who have a pet named Quigley. That gets very expensive. They have to use full text search or like pattern, and that means they have to scan the whole table. Much easier if you have that normalized in some way, and then you can search based on an index instead of parsing all this big ugly text. I also see a lot of conversations about heaps, and people will have heaps permanently, and they say, well, I don't need a clustered index. So there are some benefits to heaps. One is they're great for bulk loading. So you can bulk load into a heap and it will be very fast, and then you can pay the sorting cost after by creating the indexes after the data is loaded. You also end up getting a lot of reuse of freed space. So if you have delete and a subsequent insert, you can reuse the space that you used instead of it going to the end of a clustered index. There are some cons, though. Insert performance can be poor if the space is reclaimed. So you have this data moving all over the place because the heap doesn't really care about order. And even though you're inserting things possibly, let's say, with a date-time column, so that's always incrementing, but your data is not necessarily going in that order. So it just leads to things going all over the place. If you have updates, these lead to forwarding pointers. And if you have a lot of updates, you can be wasting a lot of pointers on pages that end up, having 5, 6, 7 chains before they get to the actual row that has the actual data. And then you get an 8 bytes per row assigned for the RID. This is the file page slot identifier in order to find that row on the disk. So this increases your row size by quite a bit. Well, I say quite a bit, but 8 bytes, if you have a billion rows, that's a lot of extra data that you're storing. All right, some T-SQL tips. So one thing I see a lot is people declaring varchar or nvarchar without a length specifier. So you'll see code like this: declare foo nvarchar is equal to bar, and then you'll get results that you don't expect. Or you'll see a varchar parameter being passed into a stored procedure. And again, I think this goes back to people just not really wanting to define what that length should be. The problem is SQL Server will decide what that length should be, and it's not consistent. It's different in a lot of cases, and I'll show a demo of that in a minute. Another thing I see is a lot of cursors out there, and while cursors are usually not the best way to do things, I understand that some things are for maintenance, some things are just easier to do to perform as a cursor. Some things are actually better as a cursor. So if you are on a version of SQL Server less than 2012, running totals is still something that I would use a cursor for. There are some other ways to do it that are faster, but they're not supported, they're not guaranteed to work the way you expect. And so I would fall back to a cursor for that. One of the problems with cursors is people usually define it as this top line here where they just say declare C cursor for and then write their query. A default cursor in SQL Server is global, which means that it is accessible to a calling scope. It is dynamic, it is scrollable, and it is, there's one other thing. It's writable. So you have all of these options that are set up for this cursor so that people can do update where current of, and they can scroll forward and scroll backward and do all of these things in a cursor. Whereas in most cases, what I see in applications is people using a cursor and they're doing one single pass through the data. So a fire hose cursor, they're processing each row once and that's it, and then discarding. So there's a huge performance gain if you define these two options, local and fast forward, specifying to SQL Server, hey, I don't need to put these results in TempDB. I don't need to scroll forward and backward. I don't need to perform any updates against this data. I'm using it in my own statements. You can still say update the base table where some key is equal to the variable in the cursor. That's no problem. It's just this special where current of syntax that I actually don't usually see being used. Another one, I'm going to have a good quiz in a minute where I'm going to ask you guys to write things down and see if you get the answers right. And I think you'll be surprised how many people get this wrong. So shorthand in T-SQL is, I think a lot of people think that it improves their productivity. So if I type Y or D or M or W for my date parts, for example, I'm going to get my work done much quicker and I'm going to get to go on vacation sooner and all of this. And I prefer to take the extra 8 microseconds it takes to write week or year or day or month and make my code much more self-documenting. But not just for self-documentation, there's a much more important reason why you're going to want to do this. Another one is this lazy shorthand that people have always used for get date +1, get date -1. So these are to find tomorrow, to find yesterday. There's a reason you're going to want to stop doing that as well. I'm also going to show how important it is to always specify the schema prefix. So a lot of people will say select columns from employees instead of dbo.employees. And a lot of people are doing that because they only have one schema. And it has always worked, and so it will continue to work. Well, more and more database designs are incorporating schemas, and you're going to have different users with different default schemas, and I'll show you why you want to be careful about that. So let's go into a couple of these demos. All right. So varchar length. I'm going to declare at x as a varchar equal to Aaron, and I would like you to write down what you think the results of these three queries will be. And I'll give you 10 seconds or 20 seconds to do that, and then I'll run this and we'll see if you got them right. All right, time's up. So when I declared a variable, varchar is equal to Aaron, so 5 characters. When I select variable is equal to @x, I get A. When I select concat is equal to concatenate @x to underscore Bertrand, I don't get Aaron Bertrand, I get A underscore Bertrand. But when I say convert is equal to convert varchar Aaron, I get the whole set. Interesting, right? I'd be curious to know how many people got that one, got all 3 of those correct. So the problem is that when you don't specify a length, you're telling SQL Server you don't care what length it applies. And in some cases, it will be a varchar 1. In some cases, and the IntelliSense tooltips are incorrect here. In this case, this will actually be a varchar 30. Now I could tell you I could enumerate all of the different scenarios where that'll be a 1 and where it'll be a 30, but I don't want to do that because I don't want you to rely on that, and it could change. I don't think this is documented anywhere that this is how SQL Server will assign these. And if it is, it still could change in the future. So I would just recommend always using the explicit lengths. So here we can see if I say declare at x varchar 64 and run the exact same query, we actually get what we expected. So you get my full name, my full first name at the beginning here. Now there are cases where this can be really bad. So if I have a procedure that has a parameter called @b, which is a varchar without a length, and then another one that is a varchar that is too short. So let's create this store procedure. And now I'm going to execute that store procedure with 2 strings that are obviously larger than 30 characters and 5 characters. And what we see on the output is we get G for the first string and great for the second string. So the first parameter was converted to a varchar 1. The second parameter was not long enough to hold the string that we passed to it. But you notice we didn't get an error message. So this is silent truncation, and what that means is you've lost that data. So if you've inserted that into a table and you have 1 character when you were supposed to have 30, that can be bad, right? So you always want to specify the exact lengths that you need and make sure that they are always matched to the underlying table. There's no way to recover that data. It's not logged anywhere. It's gone. There are other cases where declaring a varchar will actually yield an error, right? Just like you would if you created a column that said varchar 30 and you tried to stuff 60 characters into it, you're going to get this error as well. So in this case, I have a table variable that has x as a varchar. This becomes a varchar 1. If I try to put more than 3 characters into it, unlike a parameter or variable, I actually get an error message. And this is, I think, everybody's favorite SQL Server error message. String of binary data would be truncated. All right, onto the cursor. So once again, I'm going to clean my procedure cache and my buffers so that you know I'm not fooling around here with anything by running one sample before the other. So what I'm doing here is I have an integer that's just going to hold the output from the cursor. I've got a datetime2 variable, which is just going to track how long this takes. So essentially what I have is a cursor for select c1.name from sysobjects as c1, and then I'm cross-joining to 400 other rows from sysobjects. This is just to generate enough rows. The query that you use here isn't really important. This is just to generate enough rows where I can demonstrate a substantial difference in the speed. So I'm going to open the cursor, fetch into it, and while the cursor is not closed or not at the end, I'm just going to append a variable to a string. Nothing really all that fancy here. I'm going to close the cursor, deallocate it, and then check how long it took. All right, so get ready to, I don't know, come up with something to talk about amongst yourselves. I'm going to run this query, and we'll see how long it takes. There we go, 15.5 seconds to run that query, to run that cursor. And all I'm doing inside, I'm not even touching any data, I'm just appending a variable. Now, if I add two options, local and fast forward, I'm going to run this whole script again, and we'll see how long it takes. Oops. That took less than 5.5 seconds. So I just improved the performance of this by more than double simply by adding those options to change the behavior from the default cursor options, which I didn't need anyway, because I'm just looping through the cursor one time. All right, another quiz. So today's date is September 17th, and I'm going to declare a datetime variable and assign today's date to it. And I would like you to write down what you think will be the result of date part W of that date. Is it 38, 5, or 39? Then I would like you to write down what you think date part M of that date is. Is it 0, 60, or 9? And then I would like you to write down what you think date part Y will be. Is it 260, 15, or 2015? All right, I'll give you a few seconds to think about that. All right, time is up. I'm going to run that. Date part W is 5. I wonder why that would be. This is not the 5th week of the year. That is clear. It's the 9th month. It's not possible for it to be the 5th week. Date part M, okay, that was thrown in there just to trick you. There's nothing fancy about M. That just represents a month. But date part Y, year 260. That's interesting, right? So what do these things actually represent? So date part W, that W actually stands for day of week, not week. So today is Thursday, and with my settings, and this will be different on your machine if you have different date first settings. In my case, that's 5. Thursday is 5. And the month we talked about, that's pretty straightforward. Y is actually day of year. Now the IntelliSense helps you here, but when you're reading code, you're not sitting there hovering over tooltips. A lot of people are going to look at this and assume, oh, date part Y, that's 2015. Obviously, what else could Y stand for but year? Well, today is the 260th day of the year. So these can be pretty hard to track down, which is why I always recommend spelling out the word of the date part. Right, so if we do this again here, you can see this is how you get the results that you actually wanted. Having all kinds of problems with my keyboard here. All right, here we go. So there we go. These are truncated, but so we get weekday. Week is actually, if you spell out week, ISO week, which has slightly different values depending on the time of the year, month, day of year, and year. All right, so this is how you should always do it. Spell it out. It takes you an extra half a second, and it just makes your code so much more reliable and easier to troubleshoot. If the other problem is the +1, -1 kind of stuff, this implicit math operations that you can apply to date time and other types. So if you just declare a DT date time is equal to get date and then select a DT +1, no problem. That's tomorrow at this time. However, if you're doing this against a column or a parameter or even against a variable and someone changes that to a date or a date time 2 or any of the new types that were introduced in 2008, that no longer works. So you're going to need to go back and check your code. If you're still running 2005, or even if you're on 2012 and you're still using date time variables or columns, and you're even thinking about switching to any of the new types, you need to look at all of your code that works against those variables or columns, because this is not something an upgrade advisor is going to catch for you. There's no way anything can parse all of your code and look for things where you're doing math operations against date time variables and have it know that it's going to break when you change to a new type. So that's something that's potentially going to be a lot of work. So I highly recommend against this. Use dateadd. Just spell out dateadd. Much easier, much more reliable. All right, schema prefixes. Do my little cleanup here. All right, so I'm going to create 2 users, and in AdventureWorks 2014, these 2 users just have, the only thing that's different about them is that they have different default schemas. Okay, so I have AB1, whose default schema is sales, and AB2, whose default schema is person. And now we're going to grant select on the DBO schema to both of these users. I'm going to create a very simple table called very original sum table. I don't even have to insert any rows into it. I keep hitting F6. I'm sorry about this. All right. So now I'm going to run this batch. This is another little tip too. I see a lot of people, and I've watched over the shoulders of people who want to test things as another user and see how some behavior is going to be different for them. And they'll ask the user for their password, and they'll create a whole new session, or maybe even an entirely separate SSMS window where they've logged in as that user and they're operating as that user. In a lot of simple cases, this isn't going to work in all cases, but in a lot of simple cases, you can use execute as user, and you will, during that time, actually behave as if you had logged in as that user. This could be a much quicker way to test things, especially if you need to test things as a lot of different users. All right, just make sure you always hit revert after. Otherwise, you're going to be stuck and you're not going to be able to perform any of the things that you're used to doing under your credentials. So I have these 2 batches, which both have the exact same query text. Select ID from some table, no schema prefix. I'm going to run as these 2 users, and I'm going to get no results because I didn't put any data in the table, but that doesn't matter. I generated, my point was to generate plans, right? So now I'm going to take a look at sysdm exec cache plans and cross-apply that to sysdm exec SQL text, so I can find all of the plans that are currently in the plan cache that involve a select against some table. And the not like is to make sure this query that I'm running now doesn't show up. So if we take a look at that, I have 2 identical queries in the plan cache that are taking up 64K. Not a big deal. It's a very simple query. If this plan was 2 megs, it might be a little bit more of a concern. You want to be very careful about how much of your plan cache you use. Now, if we go back up here, and I'm going to do something I should never do, I'm going to type in a demo, and I'm going to put a DBO prefix on this. And I'm going to put a DBO prefix on this. Now these are still the same identical queries. I'm going to clear the procedure cache again, and then I'm going to come back down here and not go too far, and I'm going to run these 2 batches again. So execute as AB1, execute as AB2, run from that table. Now all I've changed here is I've added the DBO prefix to the table in both cases. And I'm going to take a look at the plan cache again, and voila, this is what I wanted, right? I wanted the plan for that query to be stored once and used multiple times, not stored multiple times, right? So now I've basically halved the impact that this query has had on my plan cache. And we can dig a little deeper to see why this happened. If we add one more dynamic management function into this query, we can cross-apply to the plan attributes, and I wouldn't expect anyone to automatically go to this query, but I happen to know that the only difference in any of the attributes for these two queries when I did this the other way, when I did this without the schema prefix, is that the user ID was different. So let me go back just to demonstrate. If I go back here and remove the prefix again, clear the procedure cache, and I do it the old way again. Now, if we look at this user ID attribute of the query plan, we see, oh, this is why it was different. So it was actually the attribute value was 6 and 9. And if we join that against the schema table, we can immediately tell which one of these plans belong to which user because you can see the default schema. So user ID as an attribute is kind of misleading. It actually represents the default schema. All right, let's talk a little bit about query tuning. So some of the red flags that we look for when we're tuning an execution plan, there are certain things that stand out. So you want to take a look at scans. If you're getting scans but you didn't expect them, especially when you have large scans that yield few rows, that can be problematic. That can often mean that a filter is not being pushed down far enough and you're reading a lot more data than you need to be. You want to look for anything with high logical reads. If you're reading a lot of data, so maybe you've got a var binary column or a max column that is being read that shouldn't be read. You want to look at any missing index warnings, any missing statistics warnings, any lookups. Lookups are expensive because what it means is that SQL Server was able to use an index to find the rows that were in your query, but was unable to get all of the data there. So it might have had to go to the clustered index to find other columns that were in your query. So maybe that means you need to make better covering indexes. Maybe it means that you need to change the query. Maybe it's outputting, you're using select star, and you only needed 3 of the columns. And if you changed the query to reference just those 3 columns, then that lookup would go away because the index would cover it. Sort operations are very expensive. Use of distinct, and sometimes there are hidden uses of distinct. So if you use union instead of union all, for example, the union is usually enforced by because union removes duplicates and union all does not. And that is usually enforced by using a distinct sort within each set in the union. And then you need to do it again when you've concatenated all the results of the union, because you might have duplicates within a query, but you don't want to feed those into the concatenate operator, and then you might have duplicates on the set from different queries. Implicit conversions are bad. Jonathan Cahias has a really good example of varchar to nvarchar implicit conversions that crank the CPU to the hilt. You want to take a look at any spills and spools. Unbalanced parallel thread distribution is bad. This is often due to invalid stats. So you'll get an estimated row count of one number, and the actual will be much larger or much smaller, and the parallelism on that query ends up being very misbalanced, and you end up wasting a lot of effort. And then you want to look for just the pure numbers, so a severe mismatch between estimated and actual rows. And in my pre-con, I'll deal with a lot of ways that you use this information to make your queries better. There's some things that you can do to understand what the optimizer is doing. So you want to understand why the optimizer chose a certain join algorithm or strategy to satisfy the query. So 2363, this shows the stats used and the selectivity of the columns underneath there. This replaces a couple of trace flags from before 2014, so there are a couple of other ways that you can get this information. This is the one you should use going forward. 2372 shows memory used during different optimization phases, and 2373 shows all of the optimization rules that were applied and the memory that was used for each of those. 8666 adds stat thresholds to the show plan XML, so if you're digging into show plan XML to really find some fine-tuning things, you're either Paul White or there aren't too many people that would be looking to do this, but it is something that you can add. And 8675, this shows optimization stages and timing. And during the pre-con, I'll have some examples of some of these as well. There are also some trace flags to control the way the optimizer works. So if you are not getting a parallel plan and you want one, or you want to see how the performance of one would be when the optimizers are choosing one by default, you can use query trace on 8649, and this will tend to encourage a parallel plan. It's not always possible, but it will try. 8687 does the opposite. It tends to discourage a parallel plan. And again, these are things that you can do. You can set trace flags at the session level to avoid changing the actual query text or the object that the query is in. There are a bunch of flags that you can use to spend more time finding an optimal plan. So if you've ever seen the optimizer time out because it couldn't generate a plan with it, so it timed out trying to find the optimal plan, and it settled on something, even though it didn't. It probably thinks that it could have found a better one by spending more time. These are some of the trace flags that you can use to make it do that. So what this does is it increases your compile time, hopefully only the first time, and so that if it ends up with a better plan because it spent more time, and that plan is going to be executed 8 million times, that's probably better. 4136, this is a trace flag that adds option optimize for unknown to all queries. That's not what it does. It doesn't explicitly put that at the end of every query, but it makes all of your queries behave that way. 4137, if you have multiple and predicates, it prioritizes the one with the lowest selectivity instead of whatever the join order is or however the query is written. And then 4138, this turns off row goals if you're using top, fast and in exists, those kind of things that can short circuit. This will turn off the row goals for those. And then parameter sniffing. So there are several ways to thwart parameter sniffing. This is when you compile a store procedure, let's say, and it has a date time parameter. And the first time you run the store procedure, you pass it yesterday's date. And so the query that's inside the store procedure gets the sum of all of your sales totals from the date that you entered to right now. So that query will not have to do a lot of work, because it is only looking at the history from yesterday to today. So if you have a clustered index on your datetime column, it's probably going to do a seek and be able to eliminate a lot of the rows from all of history. So you'll get a very, very efficient plan. Then the next time someone runs the store procedure, they pass in a date from 2 years ago. And now the store procedure has to generate data for 2 years worth of data. Or generate sums for 2 years worth of data. But the original plan used a seek. So it's going to use that original plan because it's not going to be smart enough to realize, hey, I really need to use a different strategy here for this query. And so it's going to perform a seek against who knows how many rows and perform lookups for every one of those rows. And you're going to get very different behavior versus what you would get if you had a scan. So there are several ways that people work around that. One is kind of a hack. If you specify local variables inside your store procedure and assign the parameters to that, the optimizer can see the values in there and react to them. Another one is to use optimize for. So you can say, I want this query to optimize for really long queries, even if that ends up costing more for the really short ones than the most optimal thing. Another one is to use dynamic SQL. So if you have certain parameters or certain parameter values that cause vast discrepancies in how your plans are shaped and how your queries perform, you can use dynamic SQL to get slightly different query text, which will allow you to compile different plans for each of those variations. And the final one is that you can use option recompile at the end of each statement or at the end of any problematic statements, which will force a compilation every time, but that will make the optimizer look at the values that were actually passed into those parameters. So I had a quick demo of this, but I think I'm going to skip it so that we have time for questions.
Perfect, and we have lots of questions coming in. The first one is, when you were talking about the I/O and the CPU weighting and also the SP_what_if, are those available in all SQL versions, or is it 2005 and above, or what? Do you know?
I'm pretty sure back to 2005 at the very least. I don't have a 2000 instance handy to test it, and I learned that long after I stopped using 2000. So I'm not entirely sure if they're available in 2000. So,
Okay.
but definitely 2005 and up.
Awesome. And are you going to have the PowerPoint and demo scripts available?
Yes.
Is that on your blog?
Yes, I'll post them on my blog.
Perfect.
Blogs.sqlcentury.com.
Okay. And I'll also post that in the pane in just a second.
Okay.
What is the scope of activate a trace flag? Is it only session-wide?
You can, it depends on the trace flag. Most of the query coercing trace flags can either be set at the query level, so there's an option query trace on argument that you can add to a query to make it enforce that trace flag just for the execution of that one query. You can do it at the session level, and you can also do it at the server level, so globally.
Awesome. Very cool. What font and color style do you have on your SMS set to?
So I have a blog post about that. If you search for making SSMS pretty, you should find my blog post about that. I actually have a VS settings file that you can download to do that. And I think, let me take a look. Oh, this is using Consolus, but on my other machine, I've actually switched to the Hack font. If you do a search for Hack font, there's a slightly better font for code editors, and one of the reasons is that it differentiates very well between 0 and O, 1 and L, and capital I, so that they went about it so that you would never have this problem confusing characters.
Okay. What's the best text to learn about the various parts of the plan, such as hash match, inner join, versus read lookups, and so on?
So I would say grab the latest book by Ben Navarez and the latest book by Grant Fritchie. And I'm pretty sure Redgate still puts out a free ebook of Grant Fritchie's execution plans.
Okay. Looking at index operational stats, large 1M row table, do you have guidance for a ratio of clustered index seeks to clustered index lookups before you think there's a problem?
No, so for a lot of those things, there really isn't a magic number. It really depends on your workload, how wide those tables are, how long the typical query runs when it's performing an update. That's really an it depends. And actually, in my pre-con, one of my slides at the beginning is you're going to hear it depends a lot. There's really not a good magic number for a lot of these metrics.
Okay. Is it recommended to use ad hoc queries or stored procedures in terms of performance?
So in the old days, there was a big difference. So stored procedures were, I put air quotes around compiled, and this was a lot different from ad hoc queries. In modern versions of SQL Server, there really isn't that much difference in terms of performance. But in terms of maintainability, predictability, if you have multiple apps that are doing the same thing, there are all kinds of good reasons to centralize your queries in a stored procedure rather than put them in app code. Another reason is when you need to make changes to the queries, when you have it in app code or middle tier, you have to recompile those things and redeploy them, whereas if the queries are in a stored procedure, you just have to change the stored procedure. The deployment process is a lot simpler.
Okay. Are any of the trace flags exclusive to SQL 2014's new CE that you showed?
That I showed? I would have to check. I'll blog if any of those are 2014 only.
Okay.
2014 CE only. I'm not sure off the top of my head.
Okay. Heap representation applies to temporal and variable tables too.
So heap representation.
I'm guessing, does it apply to both temporal and variable tables?
Oh, temporary and table variables. Yeah, so for table variables, you don't really have a lot of control there. I typically will put a primary key on a table variable just to make sure that I'm not processing a lot of rows that are duplicates when I'm not expecting to. It doesn't really have anything to do with performance. And if you have enough rows in a table variable that you need to do something different for performance, you probably shouldn't be using a table variable. You should probably be using a temp table in that case. And for temp tables, yes, I do. I typically do not let a temp table be a heap, because usually if I'm putting data into a temp table, I want to work with it after, and I don't want to work with a heap. I want to work with something that's that has a clustered index and possibly additional non-clustered indexes, so that I get the best information out of SQL Server when I'm working against that table. So with the right indexes and everything else, you get much better stats. And with a heap, you can have non-clustered indexes that have stats in it, and it's still a heap. But I prefer clustered index in that case.
Okay. Performance plans, are they used by ad hoc queries, or are they only for stored procedures?
Performance plans? Execution plans?
That's what they said, performance plans, so I'm guessing it's execution plans.
Yeah, so it used to be that you would have an execution plan cached for a stored procedure, and that changed ages ago. Now it doesn't matter if it's an ad hoc query or a stored procedure. Every statement is optimized separately.
What do you think about the use of table valued parameters? Are they useful, or should I avoid them?
I love them. Compared to splitting strings or passing XML, table value parameters are definitely the way to go.
Okay. And could you say a little more about spills and spools?
Man, that might be a completely separate session. Basically, I'll talk about spills for a second. So a spill happens when SQL Server expected to be able to, let's say, sort a set of data. So SQL Server needed to do a sort, and it said, okay, I will probably need 10 megs of memory to perform this sort. And what happens is that's based on an estimate of 500 rows, let's say. And then when the query actually starts running, SQL Server says, oh, wow, there are 50,000 rows, not 500. And what happens is once it's asked for a memory grant, it can't ask for more. So the sort operator has to sort somewhere. It has these 50,000 rows that it has to sort, and it needs, let's say, 150 megs instead of 10 megs. What it has to do is it spills to tempdb, and it has to do that. It has to do that sorting on disk. Now, the more modern you get with versions of SQL Server, they've made all kinds of enhancements to tempdb along the way, where you're able to benefit from tempdb not necessarily writing that data to disk right away. So a lot of times it can operate on temporary structures without putting that data on disk. But I don't think spills are covered by any of those enhancements yet. So you want to be really careful about spills because you're basically turning your query from memory resident to disk bound.
Okay, we better wrap up because we're about to be over. So.
Okay.
Let's go ahead and go to the next slide.
Oh, sorry. Yeah, my bad.
If you like what you've heard, Aaron will be presenting at Past Summit. He has an awesome full-day pre-conference session on 50 things all SQL Server developers need to know. So your brain will be fantastically full by the end of this. And then he also has a general session of SQL Sentry's tools for tuning. Oh, also, don't forget to use the discount code 24HOP15 to save $200. Thank you for attending 50 Things All SQL Server Developers Need to Know. I'd like to thank Aaron for his time and his expertise. Again, I'd also like to thank our presenting sponsors, Microsoft, Idera, and Dell Software, and our supporting sponsors, Pyramid Analytics, SQL Sentry, and HP. I hope you enjoyed this session as much as I did. Follow along on social media with @Past24HOP and share your thoughts on the event with hashtag Past24HOP and hashtag SQLPass. Stay tuned for the next session, Hacking Expose 2, Just How Transparent is TDE with Chris Bell, happening in a few moments.
Thanks, everyone.
Thanks, Aaron.